Hello class, alright, so we continue from our previous lesson, okay. So before this, I think we stop until here, right? Okay, so we continue to nuclear energy, okay. So there are two types, okay, or two ways, right? So two ways to produce nuclear energy. So the first one, okay, is by using nuclear fission. Okay, so the nuclear fission is triggered by other particles. Okay, for instance, when uranium-235 is bound with slow neutron, the nucleus of uranium-235 okay, may split into two pieces and emit more neutron. So let's say for figure 1, right? So this is a slow neutron. So when it collide with the uranium, okay, so it will produce, okay, two other elements, okay, and the energy, and another one is the neutron. Okay, so this neutron, okay, will collide with another uranium, okay, and then produce two elements, okay, and then produce energy and also produce neutron, and then the neutron will collide again with another uranium, okay, and produce energy, okay, and two types of element and also neutron. So this will not stop. Okay, so this is the nuclear fission, okay, and then this is the nuclear fusion, right? The second one is the nuclear fission. So the nuclear fission is the combination of small atoms, okay, into a larger atom and with release of heat, okay. So this is the example of nuclear fission. So this is deuterium, okay, tritium, okay, and then it fuse, okay, and produce helium, energy, and neutron, okay. So this is the example for nuclear fusion, okay. And then the number 2, okay, it said the following equation shown a fusion reaction. Okay, so what is the energy produced? So if you want to calculate the nuclear energy, okay, we use the Einstein formula. Okay, that is E is equals to mc theta. Okay, so the first thing you have to do is you have to calculate the total, okay, the total AMU, okay, for this side first, okay, before the reaction. This is before the reaction, this is after the reaction. So before the reaction, so it already give you, okay, the mass, okay, the atomic mass, okay, for hydrogen, okay, and this is for also the hydrogen, okay. So this one you can add, right? So 2.01410, okay, plus, okay, 3.0, right, 1605, okay. So when you add this number, okay, so we will get 5, okay, 5.031, sorry, 3, this is 0, 1, 5, okay. So after that we add the after the reaction here. So after the reaction is 4.00260, okay, plus 1.00867, okay. So you got 5.01127, okay. So after that, you see which value is is higher, okay. Which value is higher? So you can see here, okay, before the reaction. Okay, so you just minus, okay, 5.03015, okay, minus 5.01127. Okay, so you got answer 0.0188, okay, 8. Okay, so this is actually in the unit of U. Okay, so this is actually the unit. The unit is U. Okay, so and then if you want to use this formula, right, E is equals to mc square. Okay, so actually the difference, okay, the difference of the value here, okay, is equals to the mass defect. So this is called as a mass defect. Alright. And then you have to use this formula to calculate the nuclear energy. So as you know, M is a mass, so mass must be in kg. So this one you have to change to kg. So how you want to change to kg? You just multiply by so 1.66 times negative 10 power of negative 27. So this is to change the mass to kg. And then you know the velocity of light is 3 times 10 power of 8. And then u square, so this one also must be u square, must be square also. So after you calculate, so you got the value 2.821 times 10 power of negative 12 joule. So this is how you want to calculate the nuclear energy for nuclear fusion. Alright. So the next part is chain reaction. So what is a chain reaction? So a chain reaction is a self-sustaining reaction in which the product of reaction can initiate another similar reaction. So as an example, you can see here for nuclear fission, right? So like this one, the neutron will collide with the uranium, right? And then produce two elements and produce energy, and also it can produce a neutron. So this neutron will collide with another uranium, and then produce another neutron. Then the neutron will continue to collide with another uranium. So this is non-stop. So it will still continuously. So it will still collide. The neutron will still collide with the another uranium. Continuously. So this is called as a chain reaction, right? So this is the example. So in a chain reaction, uranium bombarded by a neutron. So the three free neutrons, barium and tritium and krypton, and a great amount of energy are produced. So the three neutron will bombard another three uranium atoms. So this one will be continuously, And actually for the nuclear reaction, you cannot stop the nuclear reaction, You can just control, control the nuclear reaction, So because it will happen continuously until it finish, So only the way you can do is to control, uh, the amount, of reaction. Alright, so the next one is a nuclear reactor. So we use a nuclear reactor to produce energy. So actually this one they got in Japan. Japan got a nuclear reactor to produce a nuclear energy. So that nuclear energy they used to produce electricity. Electricity. The most common type of nuclear reactor in nuclear plant is called the pressurized water reactor. So this is the pressurized water reactor. So uranium-235 it use a nuclear fuel. So we fill the nuclear 235 in the fuel here. And then you see a lot of heat will be produced. So nuclear fission can be controlled by the moderator graphic. And nuclear reaction can be controlled by the boron and cadmium as a control route. So this one to absorb the neutron. So you know when the nuclear fission, right? Like this one. So they will produce a neutron. So when there are too many neutron, so the boron and cadmium will absorb, right, the neutron. So means the reaction will be slower. And then the carbon dioxide and water used as a cooling agent. Okay, because you know the water has a high specific heat capacity. Okay, so mean it can it can absorb heat. Okay, so we use water or carbon dioxide, okay, to absorb the heat, okay, from the reaction. Okay, so the next one is the lead and concrete keep the radiation inside the reactor, because you know alpha, beta and gamma, okay, they cannot penetrate to lead. Okay, so they use a lead and a concrete, okay, so to keep the radiation inside the reactor. Okay, so this is the example of the pressure water reactor. Alright, the next one, the last part, okay, so the importance of proper management of radioactive substance. So for safety precaution, so we use a lid, okay, it's used to block radioactive rays, okay. So I told you before, because alpha, beta, gamma cannot penetrate to lid, alright. And then number two, use distance controller or tongs to move radioactive material. So we cannot use our hands, okay, so we use a tongs, or we can use a robot also, okay, robot, and then we use the remote control, okay, to control the robot, okay, so this one to move the radioactive materials. Okay, and then the uniform worn by workers in nuclear plant must be kept in special bags, okay, so after they use the uniform, they have to keep in a special bags, so it will not release, okay, to the surrounding, okay. And then number four, worker in the radioactive energy station must wear a badge, okay, so the badge is called as a safety badge, okay. So let's say the badge, alright, change color, okay, so means the worker is actually already exposed to the radioactive substance, okay, so they have to use a safety badge. Okay, and then number five, alright, the nuclear reactor should be built on island or areas far away from resident. Okay, so this is the safety precaution. So I guess we already finished, right, our chapter 10. Okay, so I give you the exercise, right, for chapter 10. So I hope you can try, okay, first, and I will give the answer, alright, in the group. Okay, so you can check after you answer the exercise, alright. So I think we stop until here, alright. So after this we can do a revision. Yeah, so thank you class.